Thank you very much. When we look at our sky at night, we see sources of light that we're all familiar with. We see stars and gas and planets. But a question that has perplexed astronomers for many decades is, when you take all of this into account, there's still a little bit that's left over. And that's this mysterious glow that you see pictured on the top left. And many different theories for this have been proposed, but none of them have really stuck. One theory for this, which forms the subject of my master thesis, is a little bit counterintuitive because it says that this glow can be attributed to dark matter. Now, regular matter is everything that we're used to seeing. It's everything around us. It's all of the stars that I mentioned, and it's all of the chairs that you're sitting in. But evidence shows that that only forms a very small portion of everything that is around us in the universe. And the rest of it is, well, dark. It's invisible to us. And just like the mysterious glow, many different models for this dark matter have been proposed, and one of them is the one that I'm investigating for my project. And it's this Axion Quark Nugget model that you see shown on the top right. Now, in this particular model, you can imagine it's made up of particles that we are all familiar with as physicists, but grouped together in a slightly different way. And you can imagine they're these very large clumps that are basically about the weight of a golf ball, but condensed into the thickness of a strand of hair. And so it's these particles grouped together in a slightly different way that allow for these Axion Quark Nuggets to have an interesting interaction. When regular particles smash into these Axion Quark Nuggets, as shown in my picture on the right, it causes an interaction that releases light. And we think that this interaction that releases light might actually explain this mysterious glow that we see in our Milky Way. Now, my project looks at basically comparing what we would see in our sky if these nuggets existed through a simulation, and that's the picture on the bottom left, to the actual observed results, to this mysterious glow. And if we find some consistency between the two, then, well, first of all, that will shed some light on this, this mysterious glow that we haven't managed to put our finger on. But also that will help provide some evidence for the nature of dark matter itself, which is a very important problem that we've been thinking about for many decades in physics as well. So thank you.